pretty good. I drank my smoothie this morning and haven't really drank that much coffee. If you guys want to know a math problem that I was continually thinking about in my head this weekend, was a unit rate problem of if it takes me X amount of time to make one cut, and then we got to add some extra time for if I have to swap blades or whatever else. You guys know I complained to you about AAP having to come and cut a tree down for me because everyone lost power. So I cut up all of the other parts of that tree this weekend. So a lot of chainsawing. Lots and lots of chainsawing. There's the remnants of what I did. That's all just literally like sawdust on the ground. What up, Alex?
Why did you have to cut down a tree?
Because it was in the way of the transformer box that they had to open up and fix. So, yeah, so the math problem I had was if it takes me 2 minutes to make every cut, and I need to make this many cuts, like, am I going to be able to get this done today? All right, so we, again, just like we talked about last week, are going to skip through some stuff, like move a little quicker today, because really that Desmos activity isn't meant to be done until later this chapter, but I would love to start it today and then come back to it later. So on the 711 resource page, you have 2 circles on there. I want you and your partner to investigate those circles and see what you can figure out about them. This. Did you grab this? If not, there you go. Now, if this was pizza, does this pizza look fair?
No.
Yes. Without giving yourself time to think.
Well, no, I mean, it doesn't look fair because, like, most pieces, they have 8 slices, and, like...
Does that really matter?
To me, it does.
Now, I think this pizza looks more fair than the Domino's that I got last week.
Oh, what did you get?
Well, every time, I mean, I don't know where you guys order pizza from, and Donato's, it's like a given that the slices will be different sizes because it's Donato's. They're doing square cut pizza, which is really not square, it's rectangle cut pizza. But if we look at this pizza, and guys, it'll look nicer in your brain if you go this way, if you turn your paper that way, because now this split is in the middle. Whereas if I go this way, that split's not in the middle. Up to you of what you like better. But yes, there are 10 slices around this pizza, but I think it looks fairly fair because they're all equally sized. And if they're all equally sized, and we go to talk about the angle of this pizza, we call this theta. When we're just talking about a general angle in math, I need to email you a link. I just remembered. Yes, it's about water being blue. So, it's up because for real, it came up again this weekend, like in my just, internet perusing, and I was like, oh, I need to send that to Alex. So I want you guys to try to figure out what is the measure of one slice of pizza's central angle. That's what we call the angle in the center. Ooh, whoa. Central angle. Talk to your partner. This should not take very long. Ooh, I did not use random cards in 1A. Oh, this is really tough. I can't use random cards. I need to keep the Jenga teams. All right, I guess I'm taking volunteers today. Alex, Theta.
Are we supposed to say it?
Yeah, like what? Like Theta question mark. Like what is it?
36 degrees.
How did you get 36 degrees?
A full circle is 360 degrees divided by 10 because there's 10 different slices. 36.
So if I know that my full circle is 360 degrees, which every circle's central angle is going to be 360 because of full rotation, we know that in this instance, our theta would be 36 degrees. Depending on how many slices, we can just multiply by 36. Now, we can also work that backwards of if I want to set up a circle graph, I can make a perfect circle graph by first figuring out how many degrees they should have. So, Nate and Rick, I combined their names for a moment. Nate and Rick are car shopping. They found these cars in their price range, and we want to make a circle graph to represent their car options, right? So I want you and your partner take a moment, read the information they gave you. I mean, you can read all the questions they ask you, or you can just start working through it. Of your end goal being make a circle graph to show Nate and Rick's car choices, vehicle choices.
So pickup trucks, that should be minivans are all within the range of car.
Vehicle. Sorry, I probably said car at first. Vehicle. Anytime people say car, they're probably meaning just vehicle. I call my vehicle a car, and it's an SUV. So is it technically a car? No. But is that the nickname? Do you always blow your nose into a Kleenex?
What's a Kleenex?
It's the name brand of a tissue.
Oh,
So if somebody says, hey, grab me a Kleenex, you probably know they mean get you a tissue. Somebody says, hey, go get in the car. It's not necessarily a car. It's just a vehicle. It's just like a nickname.
and just like how bandages and band-aids.
Yes. Band-Aid is the brand. Yep. What? I mean, you're going to be wrong. Be confidently wrong.
For real, I live by that, sir. You're iconic. We love you.
Hey, so are you actually getting your math problem accomplished, though? How many total vehicles are they looking at? 30. 30, all right. So let's make sure we all agree. 30 total vehicles. I don't expect you to be done. I just wanted to make sure we all had the same total because I was eavesdropping on some conversations. Does anyone think they have figured out like a nice sort of like trick or method or technique to make this easier than what some of your classmates might be doing and want to share that? Owen?
So, like for B.
I just mean in general, but sure, if you want to talk about B, yeah, go ahead.
So you take the amount and put it as the numerator of a fraction, and then put 30 as the denominator because it's the total.
Yeah, and when you start doing that, there's kind of like something that might jump out to you about, oh, this problem's kind of nice. Each of the car amounts is divisible by 3. And if we're saying that our entire circle graph up here is going to represent the whole situation, well, these wedges, Maddie got upset and told us these are broken into 10 pizza slices. Sorry, it's not 8, but mathematically 10 feels a bit nicer. Each of those is going to get what percent? Well, yeah. So this is really, and I'm jotting this down here. This is 10%, right? Like every slice is 36 degrees, but really that's like 10% of the situation. So for what I drew in green, my original one that I just did one slice, what should this one slice represent? And what vehicle type has 1/10 here? This would be our vans. How many slices would SUVs get? Yeah, we'll just go anybody because my cards are dedicated to waiting for us to finish Jenga. And that was SUVs. How many slices for pickup trucks?
3.
3.
So then, like, I had the number 6 in my mind.
And does it make sense that we have 4 left for cars?
Yes.
Yes. Okay, well that's when, like, obviously somebody probably set this up to be nice for us. But what about when we deal with, like, real situations that are not so nice? Sorry, did you have a question or comment? I couldn't tell if the hand was up.
It was about cars.
So probably maybe slightly off topic right now. Let's come back to that if we have time. All right, so what if we start trying to analyze circle graphs? So we'll go up and down because really there's no better way to make this fit on the page, I don't think. According to the circle graphs, which continent had the largest population in 1950? Which has the largest predicted population in 2050? And do they represent the same percent of the world's population in both graphs? Let's think about A first. So actually, I'm going to try to make this bigger if possible. We'll talk to your teammate. I'm going to try to work this better for us. So I realized we want to be able to see the graphs without having to scroll back and forth, so I was just going to do this. Make lifetime a bit easier. All right, according to these graphs, which continent had, right, like past tense, largest population in 1950? We can go anybody. We can just go class answer even. Asia, pretty obviously. Now, after Asia, though, Europe is pretty substantial, and then they get pretty close, right? Like North America, South America, Africa. So I was back in 1950. I know, crazy to think about. Yes, I was not even alive back then. I know, you might think I was. Predicted population in 2050, though, still Asia, right? But anything interesting here, just if we're looking at like graph to graph? Vivian? Africa gained a huge chunk there compared, like, and something, I mean, if Africa gained, something else probably had to go down. Ada, what are you seeing? Europe went down a lot. Laurel, you got something else? You got that. Mick? Australia doesn't change, which is funny because everything in Australia is trying to kill you. Maddie, did you have a different comment?
I was about to say, South America stays like relatively the same, while like North America goes up by a bigger percent. Sorry, goes down by a bigger percent.
Okay, I was confused for a second. Yeah, North America's going down.
I know.
South America up slightly. So wait, do they represent the same percent of the world's population in both?
You think that they would? Like,
Well, no, Asia was the biggest, and Asia was the biggest. Yeah, right? Like this question's kind of confusing. Why'd they ask it? No, is 54 the same as 57? No. And even if it stayed 54%, is it the same amount of people? No, probably not. If we assume that the world's population is increasing, even like so, Did anything stay the same?
No.
Australia did. We already talked.
Yeah.
Is that 1% going to be the same as this 1%? No, because it's 1% relative to the world. All right, so about part B, which continent is predicted to have its percent of the world population increase the most? Like, if we want to make this actually like the advanced level complicated, it should really be compared to what it was previously. But if we just straight up numerically say which one is expected to go up the most, we already said this. Which one? Africa. Yeah, by 13%. I mean, South America went up by 1. Asia went up by 3. Guys, this is why I like CPM. This is some sort of legitimate graph. Like, I don't know where they got it, but when they graph real stuff, it's legitimate, like real graphing. So which continent is expected to have its portion of the total population shrink the most? Ooh, Europe. Now, does that actually mean that like people are leaving Europe? No. Well, I mean, people are always going to naturally like pass away just from natural causes. How big is Europe?
Not very big.
Not very big. How big is Africa?
Pretty big.
Huge.
There's 54 countries.
Africa can hold tons of other countries inside of it. So why do we think that the African population might go up a lot more than Europe's population? Well, even if the amount of people in Europe stayed the same, if everywhere else goes up, that percentage goes down, right? Because Europe is like landlocked, they're not getting any bigger, right? So at a certain point, you just have everyone that you can fit, or really you don't want to overcrowd. This doesn't mean people are leaving Europe. It just might mean that, well, the people that stayed didn't necessarily have kids or whatever. Like, those people are just those people, and that's who we're counting. Now it's worth less percent.
It's also because Africa isn't very dense yet.
Africa's huge.
Africa's huge, but it's like Africa's huge, but it's not very dense.
I'd be curious to compare, and we could look this up, Africa's population density versus Alaska's population density. Because Alaska's also pretty darn big, and not a lot of people live there. Alaska's population density, at least a few years ago, was approximately 1 person per square mile. Every person, if you spread out equally, could have a square mile to yourself. That's pretty small population density, right? You couldn't even see that next person, right? And then I forget what D is. Yeah, we pretty much talked about that. So, but then if we go compare land mass, and this is kind of what I was getting at, guys, especially if you're doing your homework right now, this is just interesting, like, oh, I've never, like, noticed that about the world. Any of these, like, surprise you? This is land mass. Nothing to do with population or people. This is land, like, space available. What is surprising you, Maddie?
Like, I would say that, like, it's kind of weird to me that Australia and Europe, they're pretty similar in, like, land mass. Because, like, when I think about it, I think Australia's, like, kind of tiny. But I think, like, Europe's really big because, like, my mom, she traveled to Europe. And,
Well,
like,
there's a
she
lot of
stuff.
countries in Europe.
Exactly.
That's
so, like,
the thing.
like, I just hear a lot about, like, Europe and stuff. So I'm like, huh, it must be a pretty big place. But when it's compared to Australia, which I know is small, then it's like, that's a little questionable.
Guys, look at a legitimate map, not a globe. Globes are hardly ever accurate of their sizing. Sorry to break it to you, globes are often lying to you. Just like your calculator might lie to you. If you look at an accurate scaled map of like the world, it's really interesting to compare the sizes of these countries.
I went on this like website and they present how accurate that was, but it's like it showed like you could drag a country like up or down, and like say like Mexico, since it's like really close to the equator, was really tiny. And then if you brought it up to say where like Greenland was, then it got like way bigger, so you could see like, or you could like drag Russia into the U.S. and just like see how big things are compared to a different country.
Is that talking about how globes mess it up? Or
Yeah, like I think how like when you move it like more like close to the equator, it can get like smaller. So yeah.
Well,
It's on globes.
and because who's making that globe that you bought at Target? Like just some company,
Yeah.
right? Like, do they care if it's accurate? Probably not. Where's Antarctica? Population of the continents in 09. This is legit data. In 09. Laurel? Does that really mean nobody lives there?
It's not like they're such like they're little ants. Like nobody cares about them.
Owen?
I just have a question.
Okay.
Does Australia also count with countries like Vanuatu, Palau, and Nauru?
I don't know. This is a math class. I don't know exactly what they're citing. In the textbook, it will have a citation of where they got this data from. If you're really curious, you can go check that citation.
Like I would say like it's such a small percentage that like it's rounded down.
How many degrees should 0.0002 get on the paper?
As much as the ink is to say 0.
Maybe not even that much. Like, guys, what would 1% of a circle graph be? How many degrees would 1% be?
360. 3.6.
Say it louder, Beatrix, for the people in the back. 3.6. 360 degrees divided by 100. Every 1% would be 3.6 degrees. 0.0. Guys, this is 2 tenths, hundredths, thousandths. That's 2 10,000ths of 1 degree. So do 2 10,000ths of 3.6 degrees because it's infinitesimally small. That's why we don't see it, but we do still need to talk about it if we want to be accurate and say, okay, Antarctica has 0%. It doesn't actually have 0%. It's rounded to 0%. But on the circle graph, we might not be able to see it. And this is why sometimes the circle graph isn't the best, maybe. At least, do I care about Antarctica? Do I really want to show all of the, like, depends what you're trying to work with. But here, I would argue a circle graph might not be the best if you want to care about Antarctica, because where is it? That line. Like, zoom in, and maybe we'll see it. Maddie?
Like, what do you think? Like, this is based on like your personal opinion. Like, what do you think circle graphs are like genuinely useful?
I mean, it really depends. Every situation has a type of graphing
Yeah.
that will accurately communicate what you're trying to communicate, and then also probably, and sometimes the same, but like what looks the best for what your intentions are.
Makes sense.
So when someone's presenting to like the government about, I want to do this, they're going to choose whatever graphs make it look to get their idea across, right? And try to convince people.
Yeah.
Now that graph might be skewed. Circle graphs are tougher to skew and get away with, but if people don't have their brain turned on, they probably won't notice because they don't have their brain turned on.
Also, just makes me wonder, like, who in their right mind is choosing to live in Antarctica?
Researchers, scientists, yeah, like for real, I think most of that population is scientists.
I don't think even like normal people who aren't researching out.
Beatrix calling out the normal people. Who
Oh,
wants to
no,
be
I just
normal?
mean, like, people who aren't doing research.
All right, let's hop on to Desmos, because I think we've seen circle graphs before. Probably don't need to spend too long on it. I need to activate this so you can actually get to it. So we will come back to this activity, later in this chapter. But I want you to actually read the directions, start interacting with this, and start trying to remember our slope-intercept form of a line, rules, and, yeah, my brain's getting tripped up today. I'm too tired from chainsawing yesterday.
So are you sort of like taking it off today?
I mean, my mother-in-law showed up, and she's like, hey, we're going to lunch. And I'm like, we are? She's like, yeah, we planned this yesterday. And I was like, I was not listening. So, yeah, I mean, she made me take a break.
Actually, should have. That was for
Alex?
Is it the land the plane activity?
Yes, land the plane, the new one that should have just popped up in your Desmos. And then I'm going to email you. Hold on. Let me email you this first.
About the water, why water?
Mhm.
Oh.
I Actually, I went to a swimming pool this weekend and I saw it with my own eyes.
It's enough water together, right? That's the weird thing.
Because it was like late at night and I had a swimming class and it's blue. Like there's nothing. It's like 7 o'clock, no sunlight. Blue.
So, Alex and I were talking about this the other day, just, in case no one's curious. If you actually, water's not clear, technically. Scientifically speaking, water's blue. So if you want to get into it, you can dig deeper into it, but yeah, be careful. And this all happened because Alex said something and I was like, actually, what you just said is not true. And we had this whole oh, well, that's what everyone thinks. And well, what everyone thinks is not always true. Land the plane.
Can I say a random fact about planes?
I would like you to interact with your Desmos for at least a couple minutes so I can see some data of what you're doing and what mistakes you're making.
I kind of didn't land the plane.
That's okay. This is a safe place to make mistakes.
No. I'm sorry, guys. Ow. I killed a little person.
I can retire. Having lines, like on graph paper, to guide us, or some sort of equation. I can retire now. No, I can't retire now. I would only get 40% of my retirement. It would be really bad. Well, that's how retirement works for public jobs like teaching or whatever. You got to get to a certain amount of years to get as much as you're supposed to. If you had a closer distance from the plane to the runway, yeah, sorry, but planes normally start trying to land really far away from the... Ooh, ruler, line, or guide. Put it on a graph. Coordinates. Go up? That's not very specific. Yeah, that's boring. Guys, it's not funny. It just tells me nothing, and you spent more time trying to get those little pictures in there than you did speaking math. And whoever's Annie Easley, that tells me nothing also, unless you just accidentally clicked on to the next slide. Coordinates, that's not a sentence. I could get my 4-year-old nephew to say coordinates. Guys, we need to be working on getting better and actually giving a crap. Alex.
Is this a realistic situation, or is it more is it a small scale thing?
The way in the plane activity?
Yeah.
There's all sorts of instruments and tools and everything that pilots use to help them. So how realistic is what we're doing? Probably not very realistic. How helpful is it in terms of us being able to learn about math? Should be pretty good.
People even do that. I'm
Oh, hey, in slide 4, y'all get what you asked for. Oh, now it seems like we're all doing a whole lot better. After slide 4. And guys, you might get a little frustrated or whatever, but oh, I was close. Guys, for real, planes are shooting for the very center of the runway. Because planes can even get blown, left or right while they're landing. Because, there's still enough lift that they're not quite sitting on the ground. But then if the runway's wet or anything else, like, so planes are seriously shooting for the dead middle of the runway, so they've got some buffer zone on both sides. So if it tells you you didn't land safely, you didn't land safely, go back and try it again. Alex, you doing okay, man? Because you can keep moving on to the next slide.
Yeah, I wrote my response.
Wait, I'm thinking about angles.